First, I want to thank Nestle for inviting us to this wonderful venue with a window that looks out on Corcovado and the Carmen Miranda Museum. No, unfortunately, we're not there, but I do want to thank all of the Nestle people for allowing this meeting to come off, because I know how much additional work it required to make it happen. Secondly, I want to mention that this is a very short talk. So I am going to present a variety of concepts, but only a few real numbers, and very briefly summarize a lot of studies. I can assure you that the supporting data to support most of these studies is extensive. And if we had several hours to discuss it, I would show all of the supporting data, but you have to take my word that for the concepts that I'm presenting, there were really quite a lot of supporting data. First thing we need to do is to deal with disclosures. And the fact is, I've been doing this for more than 50 years, and I've consulted for governments and non-government organizations and a host of academic societies and disease-oriented associations, a whole bunch of food and drug companies and industry trade organizations. So I'm completely conflicted. Now, I would like to say that because I've extended my vectors in all these different directions, the net vector is zero. That is, I don't think that I have any particular bias in any one direction or another, and I'm not going to talk about any particular foods. The other thing I'm not going to talk about is good nutritional practices. So, like any other macronutrient, sugar should not be consumed in amounts that interfere with satisfying the requirements for adequacy of the other essential nutrients. This is not just for sugars, it applies to all macronutrients. No macronutrient, whether it's dietary fats, proteins, carbohydrates, or sugars, should be consumed in amounts that lead to excess energy storage. That is, one should not be overeating any nutrient, including sugars. So this talk is going to focus on whether or not sugars per se have all of the bad characteristics that are commonly attributed to them. And as I think I may have alluded to in the beginning, this is a somewhat controversial subject, except maybe it's not, because I think the nutrition community has already established what they believe the answer is, and I think I'm the only pediatrician left on the side that says, well, maybe one should look at this more carefully or more calmly. So we're used to thinking about essential nutrients from the perspective of whether or not one needs to take them in the diet. And in the course of evolution, 2 fatty acids and 8 or 9 amino acids can no longer be made by human beings, and they have to be taken in the diet. They are dietary essential nutrients. But humans can make every sugar that's necessary for life. In other words, from Mother Nature's perspective, sugars are the most essential nutrients because Mother Nature has not allowed adequacy of sugars for metabolism to be left for chance by what happens to be in the diet. Now, does this make any sense if sugars were inherently toxic? Why would Mother Nature retain the ability to make the toxic substances and leave the others out for chance? It makes no evolutionary sense. There are a variety of other metabolic things that don't make much nutritional sense if sugars are toxic. So glucose is the only important fetal fuel. The mother takes in nutrients and foods of all kinds, and across the world takes in vastly different diets, and yet all of those diets eventually reduce to glucose going to the fetus. This makes absolutely no evolutionary sense that one should leave that one should make the dependency of the next generation on something that's toxic. Infants are born with sweet taste receptors. Again, doesn't make sense if glucose is, or sugars are toxic. About a third of the calories in human milk are sugar, far more than in many other species. And we've only recently learned that infants are born with a gut-to-brain sugar-sensing pathway that promotes the development of a behavioral preference for sugar. Why does this pathway exist if these are toxins? And glucose is the only preferred fuel of the brain. Yes, you can make the brain eat some other substances like ketones, but the brain doesn't want to do that, and it's only under extraordinary circumstances that it happens. And up to the age of about 6 or so, when the brain is essentially adult size, the body needs to produce sugars at about 3 times the adult rate in order to meet the requirements of the brain, because the child has, the infant and toddler has a brain size that's far bigger in proportion to body size than the adult. The other thing you need to know about metabolism and the brain is that some carbohydrate needs to come in from the outside to maintain body adequacy. So the brain irreversibly metabolizes glucose to carbon dioxide, which is expired. In other words, that carbon has left the body. So to continue to supply carbon for glucose for the brain, one has to either have dietary carbohydrate, which can of course be complex carbohydrates as well as sugars. If one doesn't have enough dietary carbohydrate, which is a significant amount in the first several years of life, one needs to make glucose by gluconeogenesis. Now that process, which most of us learned in biochemistry, includes the Cori cycle, where glucose becomes pyruvate or lactate, recycles and becomes glucose again. That's a gluconeogenic process, but it does not make new glucose carbon. It recycles old glucose carbon, and some very clever person called it gluco-oldogenesis. To get new carbon to glucose, one needs to break down amino acids, where the carbon is generally released as alanine in large amounts, which comes back to the liver and made into glucose, where the glucose carbon can then go to the brain. So if there are no dietary carbohydrates coming in, one breaks down muscle to feed the brain. Obviously, this is not a great process over time. So even though glucose itself is not an essential dietary nutrient, okay, it is essential in the context of allowing us to feed the brain. The other thing that you need to remember is children have a very great capacity to metabolize sugar. Now, back in the late 1960s and early 1970s, in the hope of finding ways to establish early family members who would develop type 1 diabetes when one sibling developed type 1 diabetes, the endocrine community did thousands of glucose tolerance tests in normal children. These are the results of 2 studies in 300 children. And what you can see in the left-hand slide, where I've arbitrarily drawn a level of 120 milligrams per deciliter, almost the entire course of a glucose tolerance test, a large amount of glucose given to children, almost the entire time their blood glucose is below 120 milligrams per deciliter. In fact, in about 10% of children, one cannot even convincingly find a glucose peak. The right-hand panel, which shows another 200 children, by 1 hour, 50% are less than 110 milligrams per deciliter. In other words, lean children are very good at disposing of glucose that comes in via the mouth. Now, years ago, 12 to 20 years ago, Agneta Sunahag, Maury Heyman, myself, Nancy Butte, Janet Tofolo, Margarita Truth, and others did a host of studies, or a variety of studies in children, when these subjects were given a week of a 30% carbohydrate energy diet, followed by a washout period, and then a 60% energy diet, and in a crossover fashion. There were about 36 subjects, 12 lean prepubertal subjects, 12 lean adolescents, and 12 obese adolescents. And even though the study wasn't designed for this purpose, the diets provided 6 to 24% of energy as fructose. When children were consuming, after they consumed these diets, energy expenditure measured with full room calorimetry matched energy intake, irrespective of the amount of carbohydrate. Fuel oxidation measured from the RQ matched dietary, in the calorimeter, matched dietary macronutrient content. In other words, as soon as children go from low to high carbohydrate, or the opposite, they immediately switch to fuels they're oxidizing. Using stable isotope tracers, glucose production, gluconeogenesis, and lipolysis were unchanged by the amount of carbohydrate. Using a stable isotopically labeled insulin tolerance test, insulin secretory capacity and insulin sensitivity were high, very high. And in fact, in lean children, doubling the carbohydrate content of the diet, children were able to deal with this just by increasing insulin sensitivity. They did not change insulin secretion very much. On the other hand, in order to match doubling the carbohydrate content of the diet, obese children who already were hyperinsulinemic needed to increase their insulin secretion. Furthermore, whether the fructose intake was 6% to 24% of dietary energy, it had no effect on any of the adult variables. So, lean children do very well, irrespective of an extremely wide intake of carbohydrate and sugars. Now, today, a great fraction of the literature is devoted to whether sugars have long-term consequences. And because we have almost no long-term interventional studies, we depend on observational studies. So in the top panel here, we have the risk of cancer, depending on the number of cigarettes one smokes. People are fond of saying, well, there's no randomized controlled trial for smoking and cancer. Well, that's true. But let's look at the relative risks here. They're on the order of 40 or 60 or 50. And, the lower ones are on the order of 20 or 10. Whoops. This is just, the risk of cardiovascular disease or death, depending upon one's income. And if you're poor, you have a risk of, 4 to 6 times of dying or death, the risk of fatal cardiovascular disease, just by your income. I might also mention that between the ages of about 15 and 60, just being a man versus a woman raises your relative risk of dying by a factor of about 2. Now, almost all nutritional risks are less than 2. Almost all of the risks of sugar consumption found in observational studies are less than 1.5, some even significantly less than 1.5. Can we even feel confident about assigning levels of risk like that, given the methods we have of estimating them? So you'll read thousands of observational studies, and they present models which look all very simple. But the fact is, conclusions drawn from observational studies are just not as simple as that people who publish them would like you to believe. So the first is, no matter how good the observational study, it cannot prove causality. Okay. Associations from observational studies are hypotheses, they're not answers. Now, the people who do studies of this sort would like to imply causality, and this is frequently done. But the fact is, these are associations and not proof of causality. Then, if one attempts to show a causal relationship or a relationship between consuming sugars and some long-term event, what do we need to know? Well, first we need to know what the people actually ate. Now, it's maybe surprising to some people in the audience, but we can't measure energy intake very well. In hundreds of studies where dietary recall instruments are matched against doubly labeled water, energy intake is underreported on the order of 20%. And no surprise, it's underreported to a greater amount in obese individuals. In addition, many of the reported energy intakes are just simply incompatible with life. They're below what we know the resting energy expenditure is. They're impossible. Corrections are often made for this. Often the data are, the lower end of the data are dropped out or things of this sort. But the fact is, we know from this fact alone that the reported intakes are just not correct. And you'd be amazed how many adults with BMIs of 40 or 50 have energy intakes of 1,200 calories a day. Absolutely impossible. Years ago, on the order of 10 to 20 years ago now, Tom Baranowski did a series of studies where he brought children into an eating lab on day 1, and what they ate was observed. And then on day 2, they were asked what they ate on day 1, either by traditional human observer, approaches, or by some software type. And on the order of 18%, 12 to 25% of children on the second day reported foods they didn't eat, which we know, or what Tom knew, from the observations done on day 1, completely made up. Okay. Then we need to know the nutrient contents of the food individuals ate. Now, I don't have time to talk about this. You can talk about it for an hour, but nutrient contents of individual foods vary widely depending on the cultivar, when they're grown, how they're stored, how they're cooked. Almost never are these taken into account in an observational study. One goes to a dietary table, one takes the content, and one, calculates how much they ate. Next, we need to adjust for the confounding personal and environmental variables. And as I think most of you know, it's traditional 20th century observational nutrition to correct for 5 of these, maybe even 10. We now know that that's, frankly, completely inadequate. All the recent big data studies have shown us how immensely complicated the exosome or the environmental interrelated variables are. So this is one variable in NHANES that's represented around the periphery of this circle, okay? And its connections to other variables are shown in the orange lines, and then there are some blue ones. These are positive associations, and there are some blue ones which are negative associations. But I think you can see just this one variable has more than 500 interconnected interdependencies in the exosome. So corrections for 5 or 10 or even 20 are just completely inadequate in today's, level of science. So the idea that one can isolate a single nutrient and an outcome just really isn't plausible anymore. Now, with regard to these consequences, okay, there are now hundreds of studies in the literature, and we can go through those if we had time. We already don't have time. So I'm referring back to the UK Scientific Advisory Committee on Nutrition, Carbohydrates and Health report published in 2015. It was 9 years in the making. It's a 384-page report, and the committee provided almost 2,800 pages of supporting documents. So we're not going to see any study like this for a long time. Since 2015, there are other studies that have appeared. In my estimation, by and large, they don't really change the conclusions of the Carbohydrates and Health report. And what did that report, report? When it comes to dietary sugars intake, there was no association with their effect on coronary events, blood pressure, cholesterol, fasting triglycerides, blood glucose, insulin, or the risk of type 2 diabetes. From cohort studies, there was insufficient evidence to conclude that the mono and disaccharides were associated with cardiovascular events, sugars with stroke, fructose with hypertension, and on and on and on. Sugar-sweetened beverages and insulinemia, insulin resistance, and insulin sensitivity. And the few randomized controlled trials that existed, there was insufficient evidence to show sugar-rich foods had any effect on energy intake, on glycemia, vascular complications, CRP, insulinemia, insulin resistance, etc. Now, in truth, the UK Carbohydrates and Health report identified a number of associations that appeared to be positive, primarily from cohort studies. But in every case, they note that given the confounding variables, it's just impossible to conclude that one nutrient, in this case sugar, is the responsible party. And they also point out, in almost every case, the very low level of rigor in a variety of these studies. That is, they're not graded very highly. So what's my take-home message? My take-home message is that Mother Nature herself has demonstrated that sugars are the essential metabolic coin of the realm. Okay, essentially all metabolism takes place, or a great fraction of it, via sugars. Lean children metabolize sugars very efficiently. And the observational evidence in adults that sugars are causally responsible for most of the detrimental outcomes is weak at best. Moreover, adverse outcomes are strongly dependent on the maintenance of energy balance. And in fact, one of the additional things that falls out of most of the adult studies is that sugar-sweetened beverages appear to be different than other dietary sources of the same sugars, and that's a whole other subject. And finally, given all of this, we should be focusing our policies and our interventions on the whole diet with the aim of preventing obesity. That is the real culprit, not sugars per se. So thank you very much.